All right, gang. So today we're going to continue with some inequalities and turn them into word problems, or turn some word problems into inequalities that have to be solved. Let's take a look at the steps. First, you're going to determine keywords given that represent the inequality symbol needed. So greater than, less than, maximum, minimum, at least, at most are those keywords that you want to look for. When we're talking about at least, at most, maximum and minimum, it's usually the sign that kind of seems like the opposite. So maximum would be less than or equal to, because you want that number to be the most it can get to. Minimum would be greater than or equal to, because you want that minimum number to be the smallest number it can be. Okay, at least would mean greater than or equal to it as well, because you want that to be the smallest possible number. At most would be less than or equal to it again, because that would be the highest number. So that's number one. Number two, translate the problem into the inequality. Use inverse operations to isolate the variable. Remember to flip the inequality if the coefficient is negative at the end. And four, graph or list the solution set. We're not going to graph it. We're just going to list it like we were doing yesterday using bracket notation. All right. So here's our first problem. A person weighing 126 pounds has a 6-pound backpack. According to a fitness magazine, to avoid injury, 3 times the weight of your backpack and its contents should be less than your weight. What is the maximum weight of the contents of your backpack? All right, so this sounds tricky. We need to work through it carefully. Now, it says maximum. So maximum, remember, like I was just saying, we need the opposite of that sign. So maximum is going to be less than or equal to. All right, and let's think about this again. A person weighing 126 pounds has a 6-pound backpack. According to a fitness magazine, to avoid injury, 3 times the weight of your backpack and its contents should be less than your weight. So we know the backpack is 6 pounds. We don't know what's in the backpack. We know that 3 times that should be less than your weight. So we have 3 times the weight of your backpack and its contents has to be less than 126 pounds. Okay, now I put less than here, but here it says maximum because I was reading what it says up there. So we want it to be less than 126, then we're going to answer it as if it was maximum later. So we'll see how this pans out. We got 3 times 6 is 18, plus 3 times x is 3x, has to be less than 126. We subtract 18 from both sides. So 3x has to be less than 108. Divide by 3. And x has to be less than, well, 3 goes into 10 3 times with 1 left over. 3 goes into 18 6 times. So it has to be less than 36 pounds. So then what's the maximum? All right. So let's say it has to be a maximum integer. It has to be a whole number amount. So then we could say the maximum weight is 35 pounds. Now, if we're expressing this in bracket notation, since it's less than 36, we would put bracket negative infinity, comma, 36, parentheses, because 36 is not included in the solution set since it has to be less than 36 pounds. Now, it really wouldn't make sense for there to be a negative weight to the backpack, but if you're just answering the inequality, that's how the bracket would be set up. All right, let's take a look at another example. Number 2, in a remedial math class at the community college, only 5 chapter exams are given and an 80% must be achieved in order to take the state exit exam. Pam has completed the first 4 exams with scores of 71, 84, 79, and 81. Write an inequality to find the minimal score Pam can make on the 5th exam in order to take the state exit exam. Minimum means greater than or equal to, because that's going to be the smallest amount. Now, in case you didn't know, remedial means like a beginner math course. So They're in a college. Maybe they didn't do so well in math in high school, so they have to prove that they now really understand the math. All right, so now remember, this is a average, right? Remember, to calculate an average, you add all the numbers up, divide by the total number of numbers being added. So we know that she's completed 4 of the 5 exams, 71, 84, 79, and 81. But she has to take a fifth, so plus one more, all divided by 5. And she wants an average of at least an 80%. So we need greater than or equal to an 80. All right, now we can solve this. So we can start by getting rid of the denominator 5 by multiplying each side by 5. So that gives me 71 plus 84 plus 79 plus 81 plus x equals 8 times 5 is 40 plus the 0 is 400, not equals, greater than or equal to. Now we need to add here. There's some tricky numbers, not tricky numbers, just larger numbers. And since the goal here is just to get the problem done, I'm just going to use my calculator to quickly add those together. 71 plus 84 plus 79 plus 81 gives me a total of 315. So that's 315 plus x has to be greater than or equal to 400. Subtract the 315. So x has to be greater than or equal to 85. So what does she have to get on the 5th exam in order to take that exit test? She needs an 85 or better to take the exit test. So we're going to say Pam must achieve an 85 or better. And right in our bracket notation would be, since it's 85 or greater, bracket 85, comma, infinity. So anything higher than 85. Now, again, she's not going to get a score of 1,000, but since we're just writing the bracket notation for the inequality, that's how you would write it. Common sense, though, she really wouldn't score more than 100 unless the teacher is giving some kind of extra credit. But don't expect that at the college level. All right, number 3. All right, Jane has at least $20 in coins in her car. She has only dimes and quarters, and she knows that she has 3 times the number of quarters than dimes. Algebraically determine the minimum number of quarters Jane has. All right, so there should be a period there. I'm not sure why that's missing. All right, and we're back to some coin problems. So we set it up the same way we did the other coin problems, but we have an inequality instead of an equal sign. So we know she only has dimes and quarters. So dimes are 10 cents each, quarters are 25 cents each. We also know that she has 3 times the number of quarters than dimes. So dimes is what's being compared to, and 3 times for quarters. All right. Now, we also know that she has at least $20 in those coins. So 10 cents X plus, I'm going to change that to 75 cents X right away because 3 times a quarter is 75 cents, is at least greater than or equal to 20. So that's now 85 cents X is greater than or equal to 20. Divide by 85 cents. Now, I can't do that in my head. Let's take out my calculator. 20 divided by 0.85 is, whoa, let's make sure that's right. 20 divided by 0.85. There we go. Is 23.529. I'm going to write down this whole answer. X has to be greater than or equal to 23.52941 dot, 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 dot. Okay, so now we answer the question. I know I got a crazy decimal there. I'm showing that I found that crazy decimal answer. Algebraically determine the minimum number of quarters Jane has, minimum. So I obviously wouldn't have 23 and a half dimes. So the next possible answer would be 24. So she's going to have 24 dimes, or at least 24 dimes, and 24 times 3 is 72 quarters. Done. Okay. All right. So We've made some sense here of that problem. Let's go on to another one. Hopefully you're understanding where I'm getting all these answers from. All right. 4. Lewis is making a garden. He wants the length to be 1.5 times the width, with a perimeter of no more than 32 feet. Algebraically determine the maximum value of the width if Lewis wants both the length and width to be whole amounts. Give possible dimensions of his garden. All right, so again, maximum value of the width means less than or equal to. We have a rectangle. We're going back to a past problem. And he wants the length to be 1.5 times the width. So the width is x. The length is 1.5x. And we can start to figure out our equation. He wants the length to be 1.5 times the width. We got that. No more than 32 feet. So it has to be less than or equal to 32. So if we add up all those sides, 1.5 and 1.5, x and x, we have 1.5 and 1.5 is 3, 4, 5 x's. So 5x has to be less than or equal to 32. Dividing by 5, x has to be less than or equal to, well, 5 goes into 32 6 times with 2/5 left over. So if x has to be less than or equal to 6 2/5, but we want it to be a whole amount, then my width would be 6 feet, and my length would be 6 times 1.5, which is 9 feet. And we want it to be less than or equal to 32. If we add 6 and 6, we get 12. 9 and 9 is 18. 12 and 18 make 30, which is less than 32. So we did it correctly. All right. Let's see if we've got more for you before you're on your own. Yep, I've got one more to try with you. So now a real estate agent receives a monthly salary of $1,500 plus a 4% commission on every home sold. For what amount of monthly sales will the agent earn at least $5,000? So this real estate agent is guaranteed $1,500, okay, for the month. Then whatever they sell, they get 4% of. Okay, remember, in order to find that percent, you just multiply by the decimal value. So we're going to add 4% of those sales. And they want at least $5,000. So that's greater than or equal to $5,000. All right, solving this, minus 1,500. That's the amount they're guaranteed. So we get 4% of X has to be greater than or equal to 3,500. Dividing by 4%. X has to be greater than, and that number should be huge, because think about selling a house and you're dividing by a decimal, you're going to get a bigger answer, not a smaller answer. 3,500 divided by 0.04 is 87,500. Okay, so as long as they sell a house that's valued at $87,500, they are going to make the amount of monthly salary that they need. All right. Okay, so we are now done with the lesson, or the part of the lesson that I'm doing with you today. Go back and complete any of the parts that I did not do with you, checking in with me before you move on.